Good morning, students. Write your name and seat number in the chat box. The screen is visible. Sarthak?
Yes, sir.
टेस्ट झाली का फिजिक्सची?
हो.
किती मिळाले श्रेयश मार्क?
सर ते लेट झालं सबमिट करायला.
नाही झालं सबमिट वेळेत?
हा.
प्रत्येक चॅप्टरवर 25-25 मार्काच्या टेस्ट तयार झालेले आहेत बरं का आपल्या.
हा.
हा, फक्त सगळा सिलेबस झाल्यानंतर आपण सुरू करू. कारण बोर्डाच्या तारखा बहुतेक ह्या वेळेस परीक्षा तुमची 1.5 महिना पुढे जाण्याची शक्यता आहे, लक्षात घ्या. म्हणजे एवढ्या लवकर जर सिलेबस आपण संपवला तर तुम्ही निवांत राहाल आणि सगळं विसरून जाल असं मला वाटतं. त्याच्यामुळे आपण जरा हळू घेऊ. काय म्हणणं आहे तुमचं सगळ्यांचं? जरा डिस्कशन करा 2 मिनिटं आणि मग सुरू करूया. जर सिलेबस लवकर संपला ना, ऑक्टोबर बऱ्याच लोकांचा सिलेबस संपलेला मी बघितला. जर 15 ऑक्टोबरच्या आत जर तुमचा सिलेबस संपला असेल तर पूर्ण नोव्हेंबर, डिसेंबर, जानेवारी, फेब्रुवारी, मार्च मध्ये परीक्षा आहे. 5 महिन्यात सगळं विसरून जाल तुम्ही. तर मला असं वाटतं की आपण हळूहळू घेऊया की आणि छोट्या छोट्या टेस्ट सुरू करूया एक पुढच्या महिन्यापासून. आणि परीक्षेच्या दृष्टीने महत्वाचं तेवढंच करायचं. जे आपल्याला समजत नाही ते तुम्ही मला विचारा, ते मी तुम्हाला सांगतो. कारण काय झालेलं आहे केमिस्ट्रीचं की चॅप्टर्स खूप मोठे आहेत आणि वेटेज खूप कमी आहे. तर त्यातलं परीक्षेच्या दृष्टीने काय काय महत्वाचं आहे ते मला माहिती आहे, ते सांगतो तुम्हाला मी. कारण पेपर सेटिंगला आहे मी यावर्षी. अजून काही नक्की नाहीये प्रॅक्टिकलचं वगैरे. सगळं कोविडमुळं सगळे प्रॉब्लेम्स आहेत. तर त्याची काळजी काय करू नका. राहिलेला पाठ सुरू करूया आपण. क्रिस्टल डिफेक्ट्स और हा बोला बोला.
सर आपल्या कॉलेजची एक्झाम कधी होणार?
नाही होणार. एक्झाम घेण्यात काय अर्थ आहे का? मुलं कॉलेजला येत नाहीयेत, कशी एक्झाम घेणार?
डायरेक्ट बोर्ड का?
नाही, आपण काय करणार, ऑनलाईन परीक्षा घेणार. म्हणजे काय, पेपर आम्ही काढून ठेवलेले आहेत, पेपर तुम्हाला पाठवू आम्ही आणि तुम्ही घरीच सोडवावं लागेल ना. कारण आपल्याकडे ऑनलाईन प्लॅटफॉर्म मध्ये आपण स्ट्रक्चर्स काढू शकत नाही. लक्षात घ्या. रिगार्डिंग केमिस्ट्री, आय एम टॉकिंग अबाउट द केमिस्ट्री. जर आपण ऑनलाईन एक्झाम घेण्याचा प्रयत्न केला तर आपल्याकडे खूप लिमिटेशन्स आहेत. स्ट्रक्चर तुम्ही ऑनलाईन काढू शकत नाही. हे करता येईल की तुम्ही लिहायचं पेपरवरती, त्याचे स्क्रीनशॉट काढायचे, इन्सर्ट करायचे. हे खूप हेक्टिक काम आहे. त्याच्यामुळे तो पण ऑप्शन कट होतो. एक ऑप्शन आपल्याकडे आहे की पेपर तुम्हाला ईमेलवर पाठवायचा. तुम्ही तो टायमिंग लावून ऑनेस्टली म्हणजे आता तुम्ही ते बघून लिहिलंय का न बघता लिहिलंय हे आम्हाला कळणार नाही ना. म्हणजे त्या फक्त की तुम्हाला क्वेश्चन्स कशा प्रकारचे असतात, पॅटर्न कसा आहे, कुठल्या सेक्शन मध्ये कुठले कसे प्रश्न येणार ते ऑलरेडी 11वीत माहीत झालेले आहे. पण 12वीत एक्झामची सवय होण्यासाठी आम्ही पेपर देऊ शकतो तुम्हाला. ते तुम्ही घरी सोडवायचं आणि सबमिट करायचं. हे याच पद्धतीने परीक्षा होऊ शकते. दुसरा ऑप्शन नाही आहे आपल्याकडे. दुसरा आपल्याकडे ऑप्शन नाहीये. बाकीच्या
आणि
कॉलेजेसमध्ये
कधी स्टार्ट होणार होते?
आता सगळंच अनिश्चित आहे. लक्षात घ्या, या कोविडमुळे काय आहे की कुणालाच काही क्लिअर आयडिया नाहीये. आम्ही तर सांगितले शासनाचे आम्ही मेंबर असल्यामुळे की कुठल्याही कॉलेजने परीक्षा घेऊ नका आणि मुलांना प्रेशराईज करू नका. जर तुम्हाला एक्झाम घ्यायची असेल तर त्यांना एक आपण काय म्हणतो प्रॅक्टिस एक्झाम म्हणून त्याला म्हणायचं. म्हणजे अशी टर्मिनल एक्झाम वगैरे शब्द वापरायचे नाहीयेत त्याला. प्रॅक्टिस एक्झाम म्हणजे मुलांनी ते बघून लिहायचं किंवा घरी लिहायचं. कारण आपल्याकडे आपण एकत्र येऊ शकत नाही. लक्षात घ्या, अजून शासनाने सांगितले की वॅक्सिन आले जोपर्यंत येत नाही तोपर्यंत मुलांना कॉलेजला बोलवायचं नाही, प्रॅक्टिकल कंडक्ट करायचे नाही. हे सगळं सिच्युएशन कोविडच्या याच्यावरती अवलंबून आहे. लक्षात घ्या, तुमचं प्रॅक्टिकल कधी घ्यायचं, परीक्षा कधी घ्यायच्या किंवा कशा पद्धतीने घ्यायच्या, सगळं निश्चित आहे, प्रॉब्लेमॅटिक आहे. त्याच्यामुळे जेवढं काही मटेरियल तुम्हाला जे मी प्रोव्हाइड करतोय ना, ते फक्त तुम्ही वाचत जावा. परीक्षा कशा होतील, ऑनलाईन घ्यायचं चाललंय त्यांचं, म्हणजे अजून काही नक्की नाहीये. तो पण विचार शासनाचा सुरू आहे की ह्या वर्षीची बोर्डाची एक्झाम आहे ते ऑनलाईन कंडक्ट करूया आपण. मग ऑनलाईन जर कंडक्ट करायची म्हटलं तर मग ते सगळा पॅटर्न डिस्टर्ब होईल आपला. ऑनलाईनचं सगळं एमसीक्यू मध्ये करावं लागेल ना ते. मग लॉंग आन्सर मुलं कशी लिहिणार, रिॲक्शनचं त्याला रिॲक्शन येते का नाही हे कसं कळणार. याच्यावरती खूप कॉन्ट्रावर्सी सुरू आहे. तुम्ही त्या लेवलला नाहीये. तुम्ही फक्त आता एवढंच काम करा की जेवढं काय आम्ही शिकवलंय तेवढं व्यवस्थित वाचायचं, त्याचे आन्सर्स लिहायचे आणि एक्झामला रेडी राहायचं. आता बघा, सीईटी जवळपास
हो.
7 महिने लेट झाली. सीईटी अजून सीईटी झाली नाही. आता मला वाटतं पीसीबीची झाली. पीसीएमच्या तारखा 12 तारखेपासून आलेल्या आहेत. म्हणजे हे सगळं पुढं 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 ढकलत चाललेले आहेत. म्हणजे कसं आहे की मुलांना सगळं असं काही क्लिअर मेसेज नाहीये की तुमची एक्झाम कधी होईल. ऑलरेडी सिलेबस 25% कमी केलेला आहे. अजून लोक म्हणतात अजून कमी करा. अरे म्हटलं, कमी केल्यानंतर मग मुलांना यायचं काय? ही जी बॅच आहे ती मग तुमचा प्रॉब्लेम होईल. इंजिनिअरिंगला हे तुम्हाला प्रॉब्लेम होईल. काही कॉन्सेप्ट तुम्हाला समजणार नाहीत. लक्षात घ्या. म्हणजे अजून सिलेबस कमी करायची मागणी होती. ऑलरेडी 25% सिलेबस कमी केलेला आहे. तर ह्या सगळ्या गोष्टी अनिश्चित आहेत. त्याच्याकडे आपण लक्ष नाही द्यायचं. आपण जे टीचर सांगतायत, कारण मी त्या कमिटीवर असल्यामुळे सगळे अपडेट्स मी तुम्हाला देत राहील. आता बघा, टीचरला अजून ट्रेनिंग दिलेलं नाहीये की कुठला चॅप्टर किती मार्काला आहे, त्याच्यानंतर तो कसा शिकवायचा आहे, त्याच्यातले न्यूमरिकल्स किती मार्काला येणार आहेत. मुलांना विनाकारण टेन्शन नाही द्यायचं. ह्या गोष्टी सगळ्या लक्षात ठेवा. आपण ते नंतर चर्चा करूया. आपल्याला आधी हे संपवायचे आज. हा चॅप्टर आपल्याला संपवायचा आहे कारण यातला बराचसा पार्ट कट केलेला आहे. शेवटचा 1.9 म्हणजे जो सेमी कंडक्टर्स, मॅग्नेटिक प्रॉपर्टीज, बँड थेरी, हा जो पार्ट आहे तो सगळा उडवलेला आहे. अख्खा 1.9 हा जो पार्ट आहे ना, तो सगळा उडवलेला आहे. तर 1.9च्या अगोदरचे हे जे डिफेक्ट्स आहेत ते आज आपण संपून टाकूया. So these defects means what? Crystal defects or imperfections. Defects, already you know about this word. Defects means disorders. Defective item or defective piece, you know, some disorders are there. So these defects, we are talking about the crystal defects. Why these crystal defects are occurred? Crystal defects means these are the disorders or irregularities of the arrangement of the constituent particles. You know about the constituent particles. In case of crystals, constituent particles are nothing but the atoms or ions. So if there is a defects in particle constituents, uh, irregularities in particle constituents, it is called as defects. So this definition can be asked for 1 mark for the examination. What is mean by defects or imperfections? So in one sentence or one sentence we can write the disorders or irregularities of the arrangement of the constituent atoms. This word, this sentence is very important. Disorders or irregularities in the arrangement of the constituent particles. It is called as defects. So, in this chapter, we are considering about the point defects only. These defects uh, are the irregularities produced in the arrangement of the points. So, points are again atoms or ions in the crystalline solids. So there are mainly three types of point defects. One is styometric. It is also called as stoichiometric, but the original pronunciation is styometric point defects, then impurity defects, non-styometric point defects. This classification, it will be not asked for the examination, remember. But for the understanding purpose, I have created this chart, this table. This table is not given in your textbook also. But for the understanding, I have prepared this chart. So point defects, there are mainly three types of point defects. One is a styometric point defect. Second one is impurity defects. Then non-styometric defects. Again, styometric point defects. There are 1, 2, 3, 4 types are there. Vacancy defect, self interstitial defect, Schottky and Frenkel. These are the name of the scientists. So the defects are called as Schottky defect, Frenkel defect. So these defects are styometric defects. Then impurity defects, again there are two types of impurity defects. One is impurity substitutional impurity defect, means impurity is substituted here, and interstitial impurity defects means the impurity is at the interstitial position. We will discuss all these defects in details. Then I'm coming to the non-styometric point defects. Non-styometric point defects, there are again two types. It is again classified into two types: metal deficiency defect and metal excess defect. These are the examples: substitutional impurity defects, alloys. You know what is mean by alloys. In case of alloys, we will find this substitutional impurity defect. And again, there is one type, vacancy through the allovalent impurity. All these classification, it will be not asked for the examination, remember. But for the understanding purpose, I have given. So one by one, we will discuss this styometric defect. Again, this vacancy defect, self-interstitial defects. First, we will discuss about this styometric point defects. Before discussing about this styometric point defects, what is mean by styometry? Uh, you should understand, or you should know what is mean by styometric point defect. Styometry means what? The ratio of number of cations or anions. It is also called as number of atoms. So this ratio is fixed. It is called as styometric. So styometry is nothing but the fixed ratio of the number of atoms. Number of atoms means number of cations and anions. So this ratio is fixed. It is called as styometry. So in case of styometric point defect, this styometry remains same. Styometry remains same means this ratio remains same. So the ratio of number of cations and anions remains same. This is called as styometric point defect. So again, there are four types of styometric point defects. First one is vacancy defect. Second one is self-interstitial defect, Schottky defect, and Frenkel defect. We will discuss first this vacancy defect. So as the name suggests, vacancy is created. That's why this defect is called as vacancy defect. So we will discuss in detail. During the crystallization of solids, a particle is missing from its regular site. See, this is a regular site. The particles are this is first particle, second particle, third, fourth. So this is a regular site. So during the crystallization, what happens sometimes a particle is missing. So we can see here a vacancy is created. This vacancy is created because this particle is missing here. So this is a regular site, again this is a regular site. So this particle from this site and particle from this site is missing. So due to this missing of these particles, vacancy is created. So due to this vacancy, what happened? The density of the substance decreases because the mass decreases. See, so this vacancy defect decreases the density of the substances because there is a decrease in mass. Why there is a decrease in mass? Because the particles are missing. So the note, short note can be asked on it. Write a note on vacancy defect. So what is expected? I'm going to tell you what is expected for the examiner. So this diagram is expected. This diagram having 1 mark and this explanation having 1 mark. So point wise we have to write the explanation. Point wise means at least 4 points we have to write down. What is mean by vacancy, how the vacancy is created. So the missing particle creates vacancy. This is expected to write down, and then some of the lattice sites are vacant because the missing particles. So we have to show this vacancies. This The crystal then said to be vacancy defect. The vacancy defect can be developed when the substance is heated. This is also a very important sentence. These vacancies are created when the substance is heated. And sometimes if the crystallization process is very fast, then also vacancies are created, but it is not expected to write here. Whatever the points given in your syllabus or in your textbook, we have to write down. So point wise I have given the answer. So this is a 2 marks question. Diagram is for 1 mark and explanation is for 1 mark. So this is a vacancy defect. It is very simple defect. Sometimes the vacancies are created, particle is missing, and due to this vacancy defect, the density decreases. Remember these points. Then I'm coming to the second point, self-interstitial defect in case of elemental solids. Self-interstitial, remember this word. Interstitial position means position in between. So we can see this diagram. In this diagram, I will show what is meant by interstitial position. So this is a regular site. I will show with this red color. So this is a regular site. We can see, this is a regular site. This is a regular site. This is also the regular site. This is also the regular site of the particle. But we can see this particle is at interstitial position. So due to this particle at interstitial position, this type of defect is created. Here also we can see one particle is at interstitial position. So these are the two particles which are at interstitial position. This defect, so I think you understand what is meant by interstitial defects when some particles in the crystalline solid at the interstitial position or interstitial site. So if such type of situation is there, this defect is called as self interstitial defect. This defect occurs in the following two ways. Firstly, we will discuss about this defect. Extra particle, this is extra particle, occupies an empty interstitial space. This is also the empty interstitial space. Here is also empty interstitial space. Here also there is a empty interstitial space. So there are many empty spaces are there in the crystal lattice. So this extra particle, actually this extra particle already which is present in the crystal lattice, but only its position is changed. So firstly, the extra particle occupies the empty interstitial space. We can see in this diagrams, this particle occupies empty interstitial space. So what happens? The extra particle increases the total mass of the substance. This empty particle, sorry, this interstitial particle increases the density. The density increases because of this extra particle. Actually, this extra particle, it is present in the lattice point, but only it is shifted. it is shifted in the crystal and it becomes at interstitial position or interstitial site. So this is the first case. This is the first case of self-interstitial defect. And second case, see, in the second case, this is the regular site also. This is also the regular site. One particle lose its original site and occupies the interstitial position. So the first case and the second case is different, in which both the defects are there. Vacancy is also created and interstitial defect is created. So the second type, it is a combination of vacancy defect and interstitial defects. In these defects, what happens? There is a, see, a particle gets shifted from its original lattice point and occupies interstitial space. So in this diagram, it is clearly shown the particle from this site, it occupies the interstitial site or interstitial position. So in this, due to this, particle vacancy is created, and also it occupies the interstitial position. So there is a combination of two defects here. One is vacancy defect is already there, and another, there is a self interstitial defect. So self interstitial defect already we discussed in the first case. So in the first case, the density is increases, but in the second case, in this second case, there is a no increase or decrease in mass of the substance, because there is no here we can see no newly added particle is there. Only this particles position is changed. So due to change in position, there is no effect on the density. So the density remains same in the second case. So here it is written, this defect preserves the density, means the second type. In case of self-interstitial defect, there are two types. First one, this extra particle occupies the interstitial position, and in the second type, one particle lose its original site and occupy the interstitial site. So I think you understand this, both the examples of self-interstitial defects. There are two types. Then the third defect is Schottky defect. Schottky, it is the name of the scientist who discovered this defect. So this defect is occurred in case of ionic solid, remember. In case of ionic solid, there are equal number of cations, and anions are missing from their regular positions in the crystal lattice, creating the vacancies. Such type of paired cation anion vacancy defect is called as Schottky defect. So in case of Schottky defect, first remember this Schottky defect is observed in case of ionic solid, and ionic solid is prepared with cations and anions. So if there is a what you can say, there is a vacancy of cation and anion, we have to remember one thing here. Equal number of cations and anions are missing. Remember, equal number of cations means if one cation is missing, so equal number of anion is also. If one cation is missing, there is also one anion will be missing. So in this diagram, we can see clearly. This is a cation. This is anion, cation, anion, cation. This is a regular site. So negatively charged is anion, again cation, anion, again cation, anion, cation. So there is a missing here. So here there is a cation vacancy is created because cation is missing. And here you can see anion is missing. So if such type of situation is there, anion and cations are missing, such type of defect is called as Schottky defect. It is an example of vacancy defect because the vacancies are created, cation vacancy is created, anion vacancies are created. So this is a good example of vacancy defect. There are some conditions when this Schottky defect is occurred when there is a high degree of ionic character. This defect is occurred. The second condition is high coordination number of anion, and when there is a small difference between size of cation and size of anion. So these factors, these are the three factors or the three conditions. Because of this, Schottky defect will be occurred. So what are the effects of these consequences of Schottky defect? What will happen? The density of the substances will be decreased because the vacancies are created. See, when the vacancies are created, the density will be decreases because the mass will be decreased due to the loss of cations and anions. Here we can clearly see the cation is lost, and here we can see the anion is lost. So due to this loss of cation and anion, there is a decrease in density of the substance. Then the second effect, the electrical neutrality of the compound is preserved because equal number of cations and anions are missing. So the electrical neutrality of the compound will be preserved. There is no effect on electrical neutrality. So the crystal will be neutral because equal number of cations and anions are removed. This defect is found in ionic crystal. For example, it is given NaCl, AgBr, KCl. These are the very good examples of ionic solid. So in case of ionic solid, we can find this Schottky defect. Then I am coming to the last defect of the stoichiometric point defect. In case of stoichiometric point defect, remember stoichiometry remains same. Stoichiometry means the ratio of number of cations and anions, or the ratio of the numbers remain same. Number ratio of the sorry, one word is used there. The ratio of number of atoms. Number of atoms means cations and anions remain same. This is called as stoichiometric defect. So in stoichiometric defects, this is vacancy defect number one. Then self interstitial. There are two types again. Then third one is vacancy Schottky defect, and fourth one is Frenkel defect. So in case of Frenkel defect, it is also occurred in case of ionic solids. So this Schottky defect and Frenkel defect, it occurs in case of ionic solids when cation or anion, usually smaller cation. Remember, smaller cation, we can see here the size of the cation is small. So when the Frenkel defect occurred, in case of ionic solids, when cation or anion, particularly smaller cation, lose its lattice site. So the cation, we can see here, the vacancy is created. The vacancy is created because the cation lose its original position, and it acquires the interstitial position here. We can see here this cation, it's lose its original position and acquires the interstitial position here. Here also we can see here the vacancy, it is created due to the cation, and this cation, it is shifted here, means only there is a uh, change in position. So here in case of Frenkel defect, actually the smaller cation lose its original position and acquires the interstitial position. This defect is called as Frenkel defect. So it creates vacancy defect at its original position and interstitial defect at its new position. So also there is a combination of vacancy defect and see here, when the particle cation leaves its original position, vacancy is created and it acquires the interstitial position. So there is also the combination of vacancy defect and interstitial defects. So in case of Frenkel defect, it is regarded as a combination of vacancy defect and interstitial defect, because we can see here vacancy is created also and it acquires the interstitial position. We will see what is the effect of this Frenkel defect and conditions for the Frenkel defect. So these conditions are given here. there should be the large difference between size of the cation and anion. When there is a difference size of the cation and anion is large, this defects is found. But we can see in case of Schottky defect, here a small difference between size of the cation and anion is there. We can uh, found Schottky defect. So for the Schottky defect, size of the cation and anion should be same, nearly same. But in case of Frenkel defect, when there is a large difference between size of the cation and anion, this defect is occurred. Then a second condition is given here. The ions must have low coordination number. The ions must have the low coordination number, and we can see here in case of Schottky defect, the coordination number should be high coordination number of the ion. So the examiner can ask the question, write the difference between Frenkel defect and Schottky defect, remember. So such type of question can be created because there is a difference in Schottky defect and Frenkel defect also. In case of this Schottky defect, density of the substance will be decreased because the vacancies are created. But in case of Frenkel defect, see, in case of Frenkel defect, what will happen? The density of the chemical density and chemical properties remains unchanged. Means it will remain same. Density will remain same because we are not here. Vacancies are actually the vacancy is created, but this particle occupy. There is no loss of cation or anion. Loss of cation or anion is not there. Only the smaller cation change its original position. So in this Frenkel defect, there is no any loss of cation or anion. But in case of Schottky defect, there is a loss. See, there is a loss of anion and there is a loss of cation. So comparatively, you can understand the Frenkel defect and Schottky defect. In case of Schottky defect, the density will decrease because there is a loss of cation and anion, equal number of cation and anion. But in case of Frenkel defect, there is no loss. Only the position is changed here. Only the position of the cation it is changed because it is in smaller in size. So remember this, density and chemical properties remain same. Then electrical neutrality is also preserved because there is no loss. There is no loss of cation or anion, so the electrical neutrality will be same. But in case of Schottky defect, as equal number of cations and anions are lost, so the electrical neutrality will be again remain same. So see the difference between Frenkel defect and Schottky defect. Electrical neutrality is preserved because there is no loss of cation or anion. This defect is found in following crystals are given, examples are given, zinc sulfate, AgCl, silver chloride, AgBr, silver bromide, iodide, then calcium fluoride, CaF2. These are the some examples of Frenkel defects are given. Then B type is impurity defect. This is a impurity defect, means this is a second type of stoichiometric point defects are completed. This impurity defect, this is a main class. This is a main class of point defect. So these stoichiometric point defects are completed. Then this is the second type, B type. It is impurity defect. So in case of impurity defect, as the name itself suggests, this defect is occurred due to the impurity. So impurity defects arises due to the foreign atoms. Foreign atoms are also called as impurities. Atoms different from the host atoms. Atoms which is different from the host atoms means newly added or foreign atoms which are present in the crystal lattice, it is called as impurity. So again, there are two types of impurity defects. First one is substitutional. When the impurity is substituted, it is called as impurity substitutional defect. And when the impurity acquires the interstitial position, it is called as interstitial impurity defects. So in case of this substitutional impurity defect, the impurity is substituted, and in case of interstitial impurity defect, the impurity is at the interstitial position. So in case of substitutional impurity defect, we can see this is example of brass. In this defect, the foreign atoms are found at the crystal sites in the place of host atoms. So alloy, this is alloy, brass is alloy of copper and zinc. So regular arrangement of copper is like this. So this black colored, we can see this black colored impurity, it is substituted. So this impurity is substituted. This is impurity of zinc. We can see here this zinc impurity is substituted. Here we can see this zinc impurity is substituted. Here we can see zinc impurity is substituted. Means impurity is substituted. So such type of situation is there. It is called as substitutional impurity defects. Example is given in case of solid solutions of metals alloys. In case of brass, host copper atoms are replaced by the impurity zinc atoms. So host is copper here, and the impurity is zinc. So the original copper atoms are replaced or substituted by the zinc atoms. It is called as substitutional impurity defect. Again, there is also one example. Second one example is also vacancy through allovalent impurity. First, you should understand what is meant by this allovalent impurity. Vacancies are created by the addition of impurities of allovalent ions. So first understand what is meant by allovalent ions. Allovalent ions means these are the ions with oxidation, ions with oxidation, it means oxidation state is different. Ions with oxidation different state from that of host site, it is called as allovalent ions. So vacancies are created by the addition of impurities of allovalent ions. Allovalent ions means these are the ions which oxidation state is different than the host. By taking this example, this will be clear. So we will take this example here. If a small amount of SrCl2 impurity is added in NaCl. So this is a NaCl crystal. When this SrCl2 impurity is added during crystallization, what will happen? The added Sr2 plus ions, whose oxidation state is +2. Whose oxidation, only 1 minute is remaining, so I will explain very fast. So this added Sr2 plus ions occupy some regular sites of Na plus, whose oxidation state is +1. So what is mean by allovalent? Remember, so the oxidation state of the impurity and oxidation state of the regular Na, it is different. So when such type of situation is there, it is called as allovalent ions. To maintain the electrical neutrality, every Sr2 plus ions removes 2 Na plus ions. So here we can see here Sr2 plus impurity is added here. So 2 Na plus ions are removed.